Good day, students and viewers. You are welcome to the studios of Maths X. In our previous video, we converted numbers in other bases to base 10. In this video, my dear students and viewers, we will still be converting numbers in other bases to base 10, but we're going to add a little spice to it. Happy viewing. For our next unit, my dear students and viewers, we will be converting numbers involving fractions from other bases to base 10. I told you we'll put some spice into it. Now, fractions are decimals. I know I've used that kind of term before in our video. If you've not heard me say it before, or you're interested in what I talked about in that particular video, do go to my video on fractions. We went through a lot. We discussed types of fractions and everything you needed to know about fractions. So decimals are basically fractions. So for these fractions, the first one is saying convert the bicimal 110.011 base 2 to base 10. Notice the way I'm calling it. I didn't call it 110. No, because this is a base 2. I recognize that, and you should too. So the number is 110 point. Let me make the point more glaring. 0.011 base 2 to base 10. That's the first one we will be solving. Then for the second exercise in this unit, there are two of them. Convert the following to base 10. That is A, 21.21 base 3, B, 113 base 5. So to do this exercise, I'll need some space on this part of the board. Number one, we talked about 110.011 base 2. Like I said in the first part of our video, we're going to be going through an expansion process. And to do this time around, there is a decimal point here, my dear students and viewers. I would have you note that. So I will go through our 0, 1, and 2. On the left-hand side of the decimal, we have 3 digits. And of course, on the right-hand side of the decimal, we also have 3 digits. Now, in number systems, there is units, tens, and hundreds. Then there is also tenths, hundredths, and thousandths. And that's what we're going to be doing here. So this will be a -1. This will be a -2. And the third one here is a -3. I have to write them small. Okay, so having observed that, we're going to go through the expansion process. And to effectively do your expansion, the student must be very, very acquainted with powers of numbers. So which means, again, your multiplication must be very good. Your use of times table should be excellent. If you are one of the students still having problems with it's saying your times table offhand, you might be having challenges here because you could be using calculators on things that could be coming out of your head. So here we go. We have 1 times 2 to power 2. We are converting to base 10 from power 2, plus 1 times 2 to power 1, plus, this is a 0, definitely. I told you that in the future, once you see a 0, just let that particular expression go. But for learning, let us take it. So I've done the first 3. Then for this next part, watch this. This will be plus 0 times 2 to power -1. Observing that -1 there. plus 1 times 2 to power minus 2, observing this minus 2 that's above the 1 here. Then lastly, but not the least surely, maybe it is 1 times 2 to power minus 3. So that's what I'm doing here. Okay, this will be equal to 1 times 4 plus 1 times 2 plus 0, because 0 times 1, of course we know where that takes us, plus 0 times 1 over 2, we know where this takes us also, plus 1 times 1 over 2 to power 2, close, plus 1 times 1 over 2 to power 3. Still going on, we have 1 times 4 is 4. 1 times 2 is a 2. It's a plus sign. Plus 0, that is here. Plus 0, that is here. Plus 1, this is 1 over 4, because this is 1 over 2 to power 2 is definitely 1 over 4. Then 1 over 4 times your 1 is 1 over 4. Plus 1 over 2 to power 3 is 1 over 8. 1 over 8 times 1 is 1 over 8. Having gone through all that, I will take off the top part here. I need some space. So from here, we have that 4 plus 2 at 6 plus 0 plus 0, that is still 6. So we have a 6 plus 1 over 4 plus 1 over 8. It wouldn't hurt to take an LCM of just this side. So that is 8. My LCM, sorry, being an 8. This is 8 into 8 is 1 times 1 is 1, plus 4 into 8 is 2 times 1 is still 2. I still have my 6 here. So going by this will be 6 plus 3 over 8. And my answer is 6 whole number 3 over 8. Yes, this is in base 10. It's only in base 10 you can have this kind of fraction. So in conclusion, my 110.011 base 2 is 6 whole number 3 over 8. You can keep your answer in fractions if you like, if that sits well with you. It doesn't take anything. That is 3, 8. 8 into 3 cannot, that is 0.30. This is 3. 3, this is 24. 3 into 8 into 30 is 24. So that's 3 times. So we have a 6 and a 0. I won't go further than this. This is 7 times, which is 56. So my answer maybe would go for 110.011 base 2 is equal to 6.37 base 10. You could do that. Now let's take off the lower part because we need to write uh, solve these next ones. For the 2a, we had 2121 base 3. So once again, we have a 0, 1, and we have a minus 1 and a minus 2. Going through the expansion, my dear students and viewers, it will be 2 times 3 to power 1 plus 1 times 3 to power 0 plus 2 times 3 to power minus 1 plus 1 times 3 to power minus 2. So from here, my dear students and viewers, 2 times 3 to power 1 is 3 to power 1 is 3, right? So it's 2 times 3 plus 3 to power 0 is a 1. From laws of indices, we learned that. So that's a 1 times 1, 1 times 1, plus 3 to power minus 1 is the equivalent of 1 over 3. So that is 2 times 1 over 3, of course, then plus 3 to power minus 2 is 1 over 3 to power 2. So we have 1 times 1 over 3 to power 2. Let's treat this, let's be patient. We have 2 times 3 plus 1 times 1 plus 2 times 1 over 3 plus 1 times 1 over 9. That is 3 to power 2 is 9. From here on, we're going to put everything together. So we have a 6, that is 2 times 3 is 6. 1 times 1 is 1, my dear students and viewers, plus 2 over 3 plus 1 over 9. Find an LCM for this, for the fraction side. So we have 9 as a common LCM. 9 into 9 is 1 times 1 is 1 plus 3 into 9, 3 times 2 is 6. So here 6 plus 1 is a 7. It's waiting. So I have 7 whole number, 7 over 9. If I wish to convert this to decimal, there's no problem. I did that earlier. Let's find small space here to do some division. 9 into 7 cannot, that's 0 point. We have 70. 9 into 70, that is 7 times, which is 63. Another 7. Okay. 77. So that's it. So our 21.21 base 3, keeping my answer in decimal form, will be 7.77 base 10. That's what we have, my dear students and viewers. Let's look at the B part of this exercise. We had 24 rather 0.113 base 5. 24.113 base 5. To work this, much the same thing, you have your to the right hand side of your, to the left hand side of your decimal point, you have a 0 and a 1. To the right hand side of your decimal point, you have a -1, a -2, and a -3. I'll take some space on this side of the board again. We have here, from the left hand side, my dear students and viewers, we have 2 times 5 to power 1. Next number is a 4 plus 4 times 5 to power 0 plus, we are here now, 1. 1 times 5 to power minus 1 plus 1 times 5 to power minus 2 plus 1 times 5 to power minus 3 Sorry, this is 3. It's a 3 here. I have 5 digits, so it's 1, 2, that's 5 of them. So that's a 3 there. So going through this, expanding this, we have, first of all, 2 times 5, because 5 to power 1 is 5, my dear students and viewers, plus 4 times 1, because 5 to power 0 is 1. I said that earlier. 1 times 5 to power minus 1 is 1 over 5 from our laws of indices. That's the negative inverse, the negative index law, plus 5 to power 2 is 1 times 1 over 5 to power 2, plus 3 times 1 over 5 to power 3. I have 2 times 5 because I need to open up what 5 to power 3 is. So let's be patient again. Plus 4 times 1. I'm all out for the fractions now. So we have plus 1 times 1 over 5. That's what this one is. But here, I have 1 times 1 over 25. Because 5 to power 2, my dear students and viewers, is 25. Plus 3 times 1 over 125, because 5 to power 3 is 125. So we're going to have 3 times 125. So here, let's open it up now. We have 2 times 5, that is 10, my dear students and viewers, plus 4 times 1 is 4, my dear students and viewers, plus 1 over 5 times 1 is definitely 1 over 5, my dear students and viewers. 1 times 1 over 25 is 1 over 25, plus 3 times 1 over 125 will be 3 over 125, my dear students and viewers. For the whole number side, there will be no problem, surely. That is 10 plus 4 is 14 plus. But for this fraction side, the denominators are 5, 25, and 125. Surely the LCM will be 125. So we're going to use a common LCM here of 125, following from here. So we begin. 125 into 125 is 1 times 3. That will be 3 plus, again, 25 into 125 will be 5, my dear students and viewers, times 1. That will still be a 5, plus 5 into 125 is 25, times 1. We still have what? A 25. So going through this will be 14 plus 25 plus 5 is 30 plus 3. That would be 33 over 125. So without wasting time, our answer is 14 whole number 33 over 125. Nothing else can go into two of them. So we'll keep that fraction there the way it is. So meaning that our 24.113 base 5 is actually equal to 14 whole number 33 over 125. We could keep the answer in decimal fraction form, but I choose to keep it in fraction form. The way it is, it still means the same thing. So, my dear students and viewers, I trust you've been thoroughly enlightened on how to convert numbers in other bases to base 10, and also how to convert fractions in other bases to base 10. In our next video, I will be showing you how to add and subtract numbers in other bases. I know many of us are very acquainted with how to add in your regular base 10. I'll put you through all that. But you can also add and subtract in other bases. And that's what we'll be doing in our next video. I trust you want to learn. Until we meet again, my dear students and viewers, keep watching the videos of MathsX, like, share, and subscribe. As you do so, God bless you.